Hi there, and welcome to Ian's Engage channel. I'm Ian. In a previous video, I talked about how I had plans to incorporate block occupancy detection into Shelvington, with the ultimate goal of achieving train automation. In this video, I'm going to explain my thinking on how I'm going to approach implementing block detection. Please note though that what follows is effectively a brain dump of my thoughts, and not necessarily the best or even a possible way of achieving block detection. However, I thought it would be interesting to share my current thinking and to see how wide of the mark I am regarding setting block detection up. Okay, so before I can start laying track, I need to have at least a basic idea of how I'm going to wire the track for block detection and what type of sensors I'm going to use. There are at least two methods of determining whether a block of track is occupied or not. Optical sensors can be utilised to determine when a train passes by or over one, or current sensors can be used to determine a change in track current when a train occupies track that is being monitored. Both types of detection methods seem like good ways of tracking train movement, and both methods of detection have their pros and cons. Optical sensors are fairly cheap, and can be mounted alongside or below the track, and can be used alongside an Arduino or Raspberry Pi to provide a large sensor network. However, optical sensors can be confused by light sources around the layout. They require individual configuration. They're difficult to replace if placed below the track, and can be triggered unexpectedly, for instance by placing your hand over one. Alternatively, current sensors are fairly expensive and require sections of track to be electrically isolated from each other. They also require rolling stock axles to be modified to offer some electrical resistance so that their current can be measured when non-powered rolling stock is in the block. However, current sensors can be incorporated into existing track wiring. They offer detection of long sections of track and are easy to maintain. They can also be used alongside an Arduino or Raspberry Pi to implement a large block detection network. My initial thoughts are that I'm going to concentrate on current sensing technology, as it requires me to think about electrically isolating areas of track that I want to split into blocks. I'm going to discount under the track optical sensors simply because of maintenance issues in replacing one should it fail. However, having optical sensors alongside the track could be a definite possibility later on in the build. So, concentrating on current sensors, there are quite a few commercially available sensor units on the market, supporting all sorts of different interfaces, such as LocoNet, Railcom, and ExpressNet. The interface to use is another area I'm undecided on. My DigiKeys DR5000 is incredibly versatile, and supports lots of different interfaces and protocols, including all three I've mentioned. However, I don't want to commit to using the DR5000 as it already has a failed Wi-Fi component, and with the company going out of business, it doesn't seem sensible to be relying on a device that can't be maintained. Yamhawk, the company that has emerged from the ashes of DigiKeys, has a similar unit in development. However, production has been stalled due to a chip used in the design no longer being manufactured. Therefore, the device is currently undergoing a redesign, and who knows when it will be ready for shipping. The NCE power cab I have doesn't support Railcom, LocoNet, or any other standard interface as far as I'm aware, but please let me know if you know differently. To be honest, having used the power cab for a few months now, I'm not really a fan, so it definitely won't be my main controller for Shelvington in the long term. So where does that leave me? Well, luckily for me, current sensing devices, whatever interface they're designed to be compatible with, require wiring up in similar ways. Let's take the Yamhawk LocoNet current sensing device as an example. This unit is capable of detecting a current change on 16 separate blocks, but despite that, the wiring is quite simple and appears to be typical for this type of device. Obviously, to detect a current change, the sensor needs to be wired into each block. However, only the positive wire from each block needs to be wired into the device, and all of the blocks can share a common negative feed. Now, While I save up for the umpteen current sensing modules I'll eventually require, my plan is to wire the negative feeds directly to the DCC bus as normal. I'll then wire the positive feed from each block through a lever nut connector, or something similar, to make it easy to disconnect, to enable wiring through the current sensor when the time comes. Now, for all of this to work, each block needs to be isolated from its adjacent blocks. Blocks can either be isolated using insulated rail joiners, or the track can be cut to provide an air gap. Whether an insulated rail joiner or an air gap is used, it only needs to be present on the positive rail. I haven't completely decided how I'm going to insulate my blocks yet, but I'm leaning towards an air gap. Using an air gap will allow me to add blocks to wherever I've added track power feeds, and could be done even after the track has been laid. The plan would be to cut air gaps into the positive rail using a rotary cutting tool, such as a Dremel. So, where do I want to implement block detection on the layout? Potentially, it could be implemented everywhere, but that's probably impractical, especially in the Ledgetown Quarry Marshalling Yard and Shelfington Goods Yard, where operations will be carried out manually. My ultimate goal is to allow a train to automatically leave a storage lane, travel between stations, stopping at them along the way, then maybe travel around the loops a few times, and eventually return to a storage lane. This means that I need to consider block detection for the tricky bit, both inner and outer loops, Mantlethorpe station area, the track coming from Sill Harbour Fiddle Yard, and both tracks servicing Shelfington Station. The next decision to make is how big the blocks need to be. My current thinking is that each length of track between turnouts should be split into at least 3 blocks. This should allow for initial detection of the train travelling between the turnouts in the first block. The second block detection could be used to trigger braking, and the third to make sure that the train had stopped. I've mentioned track between the turnouts, but what about the turnouts themselves? From what I've researched, turnouts should not be included in blocks, as it can lead to confusion in software depending on which way the turnout is switched. However, as points will have their own power feeds, I'll be able to wire them for block detection should the need arise at a later date. Okay, so that's about it for this update. Like I said earlier, this was basically a brain dump of my thoughts on the subject of block detection and how I'm considering approaching it. I hope you found my ramblings interesting, at least in parts, and I haven't sent anyone to sleep. For those that are still awake and have experience with this sort of thing, I'd be very interested to know what you think. Am I heading in the right direction? Have I got something hideously wrong in my understanding? Also, while I plan on writing my own software to control trains on Shelfington eventually, do you see any problems with my approach, with a view to using JMRI, iTrain or Train Controller for instance? Alternatively, if you've got any hints, tips, useful tools or techniques to pass on to a beginner in Engage modelling, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks ever so much for watching. Hopefully I'll have another update on my progress soon. Bye.